Let's discuss beats. The phenomena of wavering of sound intensity when two waves of nearly same frequencies and amplitudes traveling in the same direction are superimposed on each other is called beats. Beats is a phenomena arising from interference of waves. If we listen a few minutes apart two sounds of very close frequencies, say 256 Hz and 260 Hz, we will not be able to discriminate between them. However, if both these sounds reach our ears simultaneously, what we hear is a sound of frequency 258 Hz, the average of the two combining frequencies. In addition, we hear a striking variation in the intensity of sound. It increases and decreases in slow, wavering beats that repeats at a frequency of 4 Hz, the difference between the frequencies of two incoming sounds. Let us find out what happens when two waves having slightly different frequencies are superposed on each other. Let the time-dependent variation of the displacements due to two sound waves at a particular location be S1 equals to A cos omega 1t and S2 equals to A cos omega 2t. Where omega 1 greater than omega 2, we have assumed for simplicity that the waves have same amplitude and phase. According to the superposition principle, the resultant displacement is S equals to S1 plus S2 equals to A cos omega 1t plus cos omega 2t. Using the trigonometric identity for cos A plus cos B, we get 2A cos omega 1 plus omega 2 divided by 2. Cos omega 1 minus omega 2 t divided by 2, which may be written as S equals to 2a cos omega bt cos omega at. If omega 1 minus omega 2 much less than omega 1, omega 2, omega a much less than omega b, where omega b equals to omega 1 minus omega 2 by 2. Omega a equals to omega 1 plus omega 2 by 2. It becomes maximum whenever cos omega bt has the value plus 1 or minus 1, which happens twice in each repetition of cosine function. Thus, the result of superposition of two waves having nearly the same frequencies is a wave with nearly same angular frequency, but its amplitude is not constant. Thus, the intensity of resultant sound varies with an angular frequency. Omega beat equals to omega b equals to omega 1 minus omega 2. Now, using the relation omega equals to 2 pi mu, the beat frequency mu beat is given by mu beat equals to mu 1 minus mu 2. Thus, we hear a waxing and waning of sound with a frequency equals to the difference between in the frequencies of the superimposing waves. First plot of a harmonic wave of frequency 11 Hz. Second plot of a harmonic wave of frequency 9 Hz. And C is superposition A and B. Musical instruments. Musicians use the beat phenomena in tuning their instruments. If an instrument is sounded against a standard frequency and tuned until the beat disappears, then the instrument is in tune with that standard.